Today, we'll run through an overview of the Devin platform, as well as see some best practices on how to get the most out of Devin. To start, we like to ask this question to our customers about what would you build with an infinite army of junior engineers? This is the kind of mental framing we like to use when thinking about what does Devin provide to you. And so Devin is an autonomous AI software engineer that works on end-to-end tasks in the software development lifecycle. And so this goes from the planning of the task, reasoning about what's needed to accomplish the task, writing the code, iterating on the code, testing it itself to make sure that the end result is successful, and then ultimately pushing a PR into your GitHub or your source control. And so Devin is focused on this full end-to-end software development lifecycle. And so there's a couple of changes about how you'd want to interact with Devin versus the typical kind of AI assistants, coding assistants you may have seen out there. So most of the typical AI coding assistants are ones that are in the AI IDE space. So these are things like GitHub Copilot, Windsurf, Cursor. These ones are one-to-one, where the AI agent lives in your IDE, and you as an engineer are kind of pair programming with the agent, working synchronously, getting quick feedback on what the agent's doing, and you're kind of working together to get to some end state. And so the agent's really speeding you up on the task you're working on in your IDE. Devin is a different approach where this agent actually runs asynchronously in the background. And so that's where this concept of think about what would you do with a team of junior engineers. So Devin is effectively this junior engineer that you can pass entire units of work to and be able to gain a lot of efficiency gains through that through this multitasking capability that's unlocked by Devin. And so this is one thing to keep in mind as we go through the demo about the difference between kind of AI assistants you work with, where you're kind of chatting with them live, getting feedback, nudging them towards the right direction, versus Devin, where ideally you're just passing an entire task to Devin, and Devin operates autonomously in the background. And so a couple things, just best practices about how to think about Devin. Same core concept of thinking about Devin like a junior engineer holds really true for getting the most out of Devin, where you want to tell Devin how you want things done, not just what you want done. And so that's where we kind of make this thing about the decision making Devin can make can be unreliable. But that's where if you specify exactly to an engineer, I want you to build this type of unit test. These are the edge cases I want you to hit. Clarify anything that might be a blocker or issue potentially with that the task you're delegating to Devin. You have much more likelihood of success for Devin to accomplish that task in the way you're planning for. And another key piece is ideally Devin has a way to verify the work Devin's doing, which is really what enables Devin to iterate and ultimately get to a good state. And so in your tasks that you pass to Devin, think about how it can verify it, whether it's through adding unit tests before the task even needs to be written or before the task at hand, whether it's integrating CI/CD, whether you want it to verify a UI change that it's making through the browser, then you might tell Devin to provide a screenshot of the change that's successfully updated. Always try to provide a way for Devin to verify the work, because that's how Devin can really iterate and get to a good end state for the task. And then lastly, you want to break down tasks into these smaller, repetitive smaller kind of well-scoped tasks. Rather than just passing one large task to Devin, you want to split them up into kind of digestible chunks, the same way you would provide this to a junior engineer. And so that's the core concept to keep in mind, is if I provided that same task in context to a junior engineer, could they accomplish that task effectively? To really illustrate this, I'll show an example for if we wanted to do a migration from Angular to React, which is a great Devin use case. The one call out you want to avoid is this kind of AI, what we call the AI magic wand trap. And so that's really instead of just passing it as one large prompt to Devin, you want to think about that's where you'll kind of get frustrated with the results, where Devin, you might just get a massive PR where it's really hard to understand the choices Devin made. It's 100,000 lines of code review. It's not very useful. And typically we've seen also the larger the sessions, the worse the performance Devin has. And finally, and this is the key difference between things like a Copilot, where you nudge the agent to the right answer. If you find yourself kind of nudging Devin a lot, doing one more thing, we typically see worse and worse performance. So a better approach with Devin would be to run multiple well-scoped Devin sessions. So maybe to start, we use Devin to actually just plan out what that migration should look like. Make a phased plan of attack for all the services and components that need to be migrated, thinking through whatever new React patterns that we need to modify to account for. Maybe we pull from some documented best practices that are listed on a blog post or on Confluence MCP. And that lists out the plan. And then we can start running multiple sessions in parallel, especially when you think about an Angular to React migration. You're going to be migrating hundreds and maybe dozens to hundreds of individual components one at a time. And so each of those could be really well-scoped Devin sessions to say, let's convert header component and all the corresponding unit tests over. Let's make sure to update the state management and the fetching logic based on our best practices, verify your work, making sure the code compiles and running those unit tests. And you could execute multiple of these Devin sessions in parallel, converting a bunch of components at a time. And so that's how you're able to get these large performance gains, is by leveraging well-scoped Devin sessions, but also being able to execute them in parallel. And that's the key benefit you get with Devin being this cloud async agent that operates in the background. And so that's how you could really speed up and like these kind of migrations and get the most benefit out of Devin, as well as improve the likelihood of success for every Devin session because they're well scoped to a good task that's verifiable. And then it also just becomes a lot easier to actually review each session, like each PR that Devin pushes out, because they're scoped down to an individual component, for example. And so it's much easier to understand the set of changes that are being made that you then can merge in and review. So that's the kind of level context I want to provide before we can dive in to the actual platform itself to see some of this in action.